The very matter that makes us up was generated long ago and far away in red giant stars. It makes good sense to revere the sun and the stars because we are their children.
So, are we our bodies?
Despite being paralyzed and not having any sensation from mid-chest to the tip of his toes as a result of a car crash, Juliano Pinto delivered the opening kick of the 2014 Brazilian World Soccer Cup here just by thinking, because he was wearing the first brain-controlled robotic vest that can be used by paraplegic, quadriplegic patients to move and to regain feedback. And in basically 13 seconds, Juliano actually did. You can see the commands, he gets ready, the ball is set, and he kicks. And the most amazing thing is, 10 seconds after he did that and looked at us in the pitch, he told us, "I felt the ball."
So it seems as though our bodies aren't always what we think them to be.
So today I would like to talk with you about bionics, which is the popular term for the science of replacing part of a living organism with a mechatronic device or a robot. Here's Amanda using an arm made by DECA Research Corporation, and I believe Dean came and presented it at Tech a few years ago. So Amanda, you can see, has really good control. It's all the pattern recognition, and it now has a hand that can do different grasps. What we do is have the patient go all the way open and think, what hand grasp pattern do I want? It goes into that mode, and then you can do up to 5 or 6 different hand grasps with this hand. Amanda, how many were you able to do with the DECA arm?
I was able to get 4, but my favorite one was just when the hand was open, because I work with kids, and so all the time you're clapping and singing, so I was able to do that again, which was really good.
Well, if we're not always our bodies, maybe we're our senses then.
Our experience of reality is constrained by our biology. And we have a word for this in science. It's called the Umwelt, which is the German word for the surrounding world. But the question is, do we have to be stuck there? I'm interested in the way that technology might expand our Umwelt and how that's going to change the experience of being human. Your brain is locked in a vault of silence and darkness inside your skull. All it ever sees are electrochemical signals that come in along different data cables, and this is all it has to work with, and nothing more. Now, amazingly, the brain is really good at taking in these signals and extracting patterns and assigning meaning, so that it takes this inner cosmos and puts together a story of this, your subjective world. Your brain doesn't know, and it doesn't care where it gets the data from. Whatever information comes in, it just figures out what to do with it. The sonic glasses take a video feed right in front of you and turn that into a sonic landscape. So as things move around and get closer and farther, it sounds like a cacophony, but after several weeks, blind people start getting pretty good at understanding what's in front of them just based on what they're hearing. The most modern incarnation is called the brain port, and this is a little electrode grid that sits on your tongue. And the video feed gets turned into these little electrotactile signals, and blind people get so good at using this that they can throw a ball into a basket, or they can navigate complex obstacle courses. They can come to see through their tongue.
I'm starting to think that we might be our brains.
The brain is an amazing and complex organ. And while many people are fascinated by the brain, They can't really tell you that much about the properties about how the brain works because we don't teach neuroscience in schools. What we can do is copy your brain signal that's going out to your hand and inject it into your hand so that your hand will move when your brain tells your hand to move. And so in a sense, she will take away your free will and you will no longer have any control over this hand, okay? You with me? All right, so I just need to hook you up. Do it again. All right, so now... All right, so right now, your brain is controlling your arm, and it's also controlling his arm. So go ahead and just do it one more time. All right, so that's perfect. So now, what would happen if I took over my control of your hand? And so just relax your hand. What happens? Nothing. Why not? Because the brain has to do it. Now you do it again. All right, that's perfect.
It seems as though our brains are becoming able to control another person's body.
So in principle, we should be able to understand the human brain as a computer by reverse engineering it and discovering the underlying computational algorithms that govern its function. Animal studies suggest that the brain is 50% connected. That is, for any given location on the cerebral cortex, it is connected to 50% of all of the other locations. And all of these connections are feed-forward and feedback. So the brain is a giant interconnected recurrent network. The property of the system as a whole, its function, cannot necessarily be predicted by looking at the individual parts, because nonlinear dynamical systems have emergent properties. And in humans, of course, one of the most important emergent properties is probably consciousness. A third of the functional activity in brains is shared across individuals, and about 2/3 reflects individual differences, which are both developmental and experiential differences. And the different colors here reflect different kinds of meaning that are represented in the patterns of brain activity about the information in the stories and movies. All of the red spots on this map represent social information. There are other networks that represent other kinds of information. For example, here's a spot in the posterior parietal cortex that represents numerical information. We can create a mathematical model that links an individual brain anatomy to the distribution of function across that brain. Once you have a computational model of the brain that relates the world to brain activity, you can invert that model, and you can convert your encoding model into a decoding model and can use it to decode brain activity. Whenever we can create a better computational model of the brain, we can always, by definition, build a better brain decoder. Here's one brain decoder that's only recovering information from primary visual cortex, a very early visual area that represents very simple aspects of the scene, like edges and textures and colors. On the upper left is the movie we showed to subjects. On the upper right is information we're decoding from primary visual cortex. And the bottom two photos show you the edge maps. These should correspond well because we know that this part of the brain represents edges. Here's a decoder that is recovering information and decoding it from high-level visual areas. So when the scene changes slowly, the decoder does quite a good job of recovering information about the semantic content of the scene. So at some point in the future, we're going to have very cheap, very powerful, portable brain decoding devices. Probably in the lifetimes of young people here, there will be a brain decoding method that is cheap, portable, very powerful, and that will become ubiquitous. Anything that is going on in your head is potentially decodable. All of your inner thoughts, your intentions, desires, your attitudes, in fact, things that haven't even reached conscious awareness yet, are potentially decodable. And all that information will be decoded using future brain decoding technology. When Google and Facebook have access to all of your innermost thoughts, with no filter from your thumbs, right? That's going to be a very strange world, but it is the world we're going to live in very soon.
The brain is a nonlinear dynamical system that changes somewhat chaotically dependent on the input. Our concept of identity to ourselves and others is malleable. Even though people look different and act differently, others may not be who or what we think of them at the time we are making our judgments. And they may be different now and in the future, both from our perspective and from theirs. It is time to teach grade schoolers our similarities because all of us are the results of the neuronal activity of our brains.